All right, welcome. Hello, good morning. If it's morning for you, hope you are having a good day, whoever you are, wherever you are. What is up, Liz? Nice to see you in the chat this morning. Let us organize a few things and then get this. Okay, that's probably just wrecked the chat for a second, but it's back to normal. Like it's back to normal. All right, here we go. We are good. I could minimize this. All right, yes, welcome. For anyone who is new and or doesn't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. Excuse me, and I stream around this time each week, 10 a.m. on Tuesdays here on the Adafruit channel, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for the project here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. Typically, the way it works with CircuitPython on these devices, you will usually plug them in with a USB cable, so they have a port there for USB. You plug it into your computer, it shows up like a thumb drive. You can edit the files on that thumb drive. There's a code.py file, a Python code file, which contains text, Python code. You can edit that, and when you save it, the microcontroller will reset and interpret and execute that Python code for you. And then the code itself can interface with whatever is connected to the microcontroller. So some devices have lots of built-in peripherals, like the Circuit Playground Express here is kind of an educational device with a load of built-in peripherals like a speaker, an IR emitter, an IR receiver, some buttons, 10 neopixels, a switch. I think there's like a temperature sensor as well. A speaker. Yeah, I think there's speaker is over here. There's a little microphone, I think, over here. So lots of stuff going on this one, all sort of built in, ready to go. Whereas others are more general purpose, like this Raspberry Pi Pico, a very cheap microcontroller, does not come with hardly anything built on. That's actually the Wi-Fi version. This one over here, though, the Pico, does not come with hardly anything built in, just basically the bare minimum in order to make the RP2040 function. So it does not have any lights or speakers or, microphones or buttons or switches or anything. You can connect all those things up using the I/O pins on the edges there, and you can write CircuitPython code, of course, to control that stuff. If you would like to help support CircuitPython, it is an open source project. It's primarily funded by Adafruit. This is their website, adafruit.com. They pay a team of folks, including myself, to work on CircuitPython and publish all the code under open source licenses. If you would like to help support the CircuitPython project and all of the rest of the open source work that Adafruit supports, you can do so by purchasing hardware from their website, adafruit.com. You can get yourself microcontrollers. You can also get yourself bits and bobs, doodads, widgets, what have you, to connect to your microcontroller in order to make fun and interesting projects with. All right, diving in today, I am back in Zephyr Portland, which I think I have been working on the last couple of streams, and I am just kind of working my way through the list of core modules that are currently enabled here, and I'm kind of comparing it to the list of core modules that exist on non-Zephyr port devices. So this list here in shared bindings is usually what I look at. This has all the core modules that are available total. Any given module might be enabled or disabled on any given device, usually as a result of how much flash there is. If there's not enough flash to hold all the stuff, then modules get disabled. If there is enough flash, then oftentimes it will just have everything that can be enabled. And so I'm just kind of going through that list and trying out enabling them in Zephyr, making sure that it works on a device, and then writing a native sim test that validates the module that confirms the behavior of the actual module itself as well. And next up is the bottom one on my list here, storage, which I had on my mind because we'll open up the PR here. A few weeks back, I added a board def for the Feather RP2040. And when I did that, I basically copied the board def from the Raspberry Pi Pico, which also uses an RP2040. It's like very similar device. It's, it's a different shaped board. It's the Adafruit Feather with the RP2040 on it. And one of the things I failed to notice at the time was when I copied it, the Pico, of course, does not have as much flash as the Feather. The Feather has I think 8 meg flash thing, and the Pico has a smaller, only 2 megs of flash. And so when I copied that, we actually got the 2 meg flash from the Pico definition, which works fine on the Feather, but it limits the amount of space that you have. The rest of that, 8 megs. The rest of that 8 megs was effectively like unusable. So I have a PR here that enables the rest of it by changing the size to 8. But what I noted here at the bottom was storage was not enabled, which meant in order to get it to take effect, I had to use the flash nuke, the flash UF2 file, I should say. Flash nuke UF2? I'm not sure. Maybe it's the full thing, flash nuke UF2. In any case, it's like a UF2 you can drop on there and it will clear out all the flash. And then reinstall CircuitPython build from this afterwards. And once I did that, I was able to see the full closer to 8 megabytes. Some of it's taken up by CircuitPython itself, so it's not the entirety of 8 megs, but it's much closer than it was before. It was showing like 1.3 or 4 or 2 or somewhere in that range. I don't know. And I don't know for sure if this is going to be as simple as just enabling it here to see if it works or not. So that's what we're about to find out together. I have made the build already before the stream started, just so we don't have to wait on the first one at the very least. I will show you here that I am plugging in the Feather. Ooh, there's clipping out a little crazy there on the bottom. We need to get to the bootloader. Actually, I should also, before we do this, check if there's anything I care about on this device, which I think is unlikely, but since we are messing with storage, and ultimately our test here is about to be... Okay, yeah, we don't need this. This was from the project I worked on over the weekend, and I have a different copy of it on a different device because Zephyr doesn't support NeoPixels yet. But I don't need the code here because I do already have it on the other Feather. I am just going to go back and reboot this into bootloader mode, and then we are going to copy this to it. So copy from build, Adafruit Feather RP, then Zephyr-CP, and then Zephyr again, and then Zephyr.uf2. And that's going to go to the RP2 drive. All right, so that disconnected. Hopefully reconnects. Okay, it reconnected. And CircuitPy is still here, which is good. The code is still here, which is good. That's what we expect at this point, because we haven't actually run the erase file system yet. We just enabled the module. I think we can go ahead and try it. Maybe one thing to check would be, let's just validate this still shows up. I mean, I don't see why it wouldn't, but yeah, okay, so we still have closer to 8. Maybe we'll keep one of these open. We still have closer to 8 megs, so that is still good there. So what we're going to do is, in fact, I'll just, well, I suppose it doesn't matter because we're about to erase it, but this is basically what it will end up with anyway. All right. So as the name suggests, this will erase the file system, so do be careful if you're happen to see this and want to follow along. Make sure you back up whatever files are on that device before you run that. It disconnects, it reconnects, it kind of reboots itself, and it comes back, and the storage should be wiped. Now, my IDE here maybe is a little slow on the uptake of noticing. I would not be surprised if it's kind of not really showing me reality, fortunately, which is a little bit annoying. So that's fascinating. So my computer definitely still sees the old content, but if we look in the REPL up here, we know that this can't be the old content. It's very subtle, but this is capitalized with H and W, and it also has an exclamation point, and the code that I put in there was lowercase and did not have an exclamation point. So the actual CircuitPython device has new code on it that my computer is not seeing right now for some reason. I'm just going to unplug it and replug it. Hope for the best. And we will probably eventually, I'll try to validate if that's like I kind of lean towards thinking that's just my computer being wonky, because like I said, sometimes it does not really notice the changes so well. Yeah, there we go. Okay, so yeah, unplug, replug, and now we have what was actually on the device before, just my computer was not seeing it. I think the computer does not really, like the OS is not expecting a drive to just disappear and reappear with completely different stuff on it. Like the exact same drive was here 1 second, it was gone for a second, it came back, and then everything on it is different. The computer, the OS is not really expecting that, basically. It's kind of an awkward behavior for a thumb drive. I would not be surprised if just it kind of freaks out the OS a little bit. But it did work. Let's check the size. There we go. Yeah, so that's still good. Closer to the 8 megs there. One thing I don't necessarily have a super clear idea on would be how to test this in the native sim. So we have, I mean, that's the other thing I've been doing is I go through and enable these modules after testing them on hardware, or sometimes before testing them on hardware. I've changed up the order on different ones, but in addition to testing them on hardware, I have been creating the tests here. So like test getPass, test hashlib, test AESIO. These are some of the modules I've enabled. And these tests run on the native sim, and they validate the behavior of the module. The storage module is a bit of a weird one, though, because when you run erase file system, it is going to reboot the device. And I have no idea if the native sim is set up to handle that, really. And I guess what the test should be is it should copy a file to the device first, make sure that file shows up and does what it's supposed to do. So like have a CodePy that prints a certain thing, copy it to the device, run it, make sure it prints the thing it's supposed to, then run storage erase file system. The device is going to reboot, and when it comes back, the test should validate that the file is gone. So it should make sure that the file itself won't be gone because CodePy will get recreated automatically. I guess we could make a different file as well. But it should make sure the contents of CodePy get wiped, and then it should also maybe make sure that if there's a different file that's not CodePy, that one should get deleted. That would probably be the test, but I don't know if the native sim will be okay with that device. Like, I have no idea what it will do when you run storage erase file system in there, basically. I don't know if it will come back correctly, and the test will be able to, like, keep checking stuff afterwards or what. And I don't think that storage is the most interesting thing in the world. So what I think I will do instead of like fully chasing that particular thing right now is move on to gifio, which I wanted to work on as well. We got the hardware test successful there, so I'm relatively confident. I'm just gonna make one branch for both, I think. Could split them up if they ask me to for a review. gifio. So this one is another one. I think honestly it should basically be as easy as just turning it on, and it should work, I think. Because all the code for gifio is in shared bindings and shared modules, which means there's no like port specific code, which means that it shouldn't really need anything special for the Zephyr build. Some devices probably won't have enough flash space for it, so it's going to have to get disabled on some. Like some of the Nordic ones have been running into that with the last couple modules. Like Nordic, this 7002. I think also one of these two, forget which, either 54, yeah, I think it's this one actually, because I remember H20, H2O for water at the end there, kind of. It's actually H2O, not, or H20, but those have overflowed the flash, so we would need to go back and disable gifio, maybe storage as well, although storage is kind of a foundational module, so realistically we might look for something else to disable instead of it. You know, like message pack or zlib, some of these don't matter nearly as much. Depends on what the device does, though. All right, while that is cooking there, why don't we go get a gifio code. Yeah. Okay, so GIF, there's two ways you can do it. One of them is inside of display IO, one of them is outside of display IO, basically. So this is the inside display IO way. And that's what I'm going to use for now. We could try testing this one as well. One thing is, though, I don't have sample GIF. There's... Okay, nice, this will work. Try that. This is awfully big. I don't suspect it will run quite so fast, but... Actually, also just gonna do this here. I can save this. I'm just gonna rename it to sample so it matches the code. So display stuff, this is already gonna be done in a different way. I'm just gonna take this part of it. And actually, I guess here's where it would be slightly nice to still have that code. I did not copy. So that code that was on there that I said I didn't need, technically didn't need it. Would have been nice to have it. But the truth is we do still have it on this one. So I'm just going to plug in, I plugged in another device here. Now this, you can barely see it, but the display there is on. And that one has the display initialization. We find the right spot of it. I should just copy these. I closed the. Some of this won't be used, but it will highlight, I think, and I can just delete them. There we go. This will initialize the display. Gifio. Time. Flash. I called main group. Why is this called flash? Or I mean face. Just gonna say sample GIF. Or instead of board display right here, we're just going to use display because it's not built in. We don't really need to call refresh, actually. Let's look at the code again. Maybe we should. No, I don't think this does anything really. So the thing is, here it's just doing display equals board display. So get the built-in display. We should update this to supervisor.runtime. But that's neither here nor there. And then it calls refresh here, and it... Yeah, that's the only place it calls refresh. It doesn't call a refresh here. But by default, auto refresh is going to be true. So this is not needed. It should refresh anyway. Now, you could make the case perhaps the GIF is going to work better if you turn auto refresh off and you do refresh explicitly when you want to, namely once at the beginning and then once whenever you change the frame. I could see potentially a case being made for that. But here, I don't think it's doing anything because auto refresh is already on by default. So we're going to save this. It's going to fail because we don't have any of the libraries, and even if we did, we don't have the display plugged in. And even if we did have both of those, we did not copy the build, which did not even succeed. So we have several layers of problems here. Let's see if we can figure out what has happened. GIF play frame undefined reference. Okay, most likely gifio actually references some other code. So let's take a look at this. On disk GIF. Interesting. Ah, there it is. No. I don't care nearly as much about GIF Writer. At some point, maybe I'll look into it, but I've never actually used GIF Writer before. Oh, am I in shared bindings? I'm in shared bindings. I think we should be in module. What I'm looking for is, like, presumably this code is importing or including, because it's C, some other module that is making this. There it is, right there, I think, maybe. Yeah, so I think this is probably including this thing, which must very likely be having this GIF play frame, which caused the build to fail because it was not found. And I actually did run into one like this before, enabling in Zephyr, and what we need to do is, in a different part of this file, there's stuff like... there's stuff like this which we need to do. So we can go gifio here as the key, and that needs to bring in what we just saw over here. Lib animated GIF. While that's running, we can run circup so that we get the libraries we need, which are not very many, just the display driver. We might as well unplug this. It's yanked out the NeoPixel wire, which is fine, we're not using them now. It will basically overpower the camera though until we get control of the display and can turn it off of full bright white. Yeah. Oh, I think it was failing. Failed the same way. Oh, I did this wrong. That should not be like that. It should probably be C. Let's look at the file and see if there's one here. Animated GIF. There's animated GIF CircuitPy, so actually H is the only one. Should be H. Okay, let's try searching one of the things that it's not finding in here. Because this would help us be sure that this is weird. There's a tick mark here, like the shift tilde, right? Or unshift tilde. But on here, it's a single quote. Subtle, but weird. Okay, yeah, totally this comes from this file. So this is not getting pulled in correctly. It's so weird that it doesn't have the C file. Is there anywhere else in here that says lib? Looks like this supports stars. We could have maybe done a star instead of all of these for zlib. let's say on a different computer, I am, well, actually, let's start this way. I like to do this. We're inside the CircuitPython repo. On a different computer, I am attempting to enable the gifio core module in the Zephyr port by adding it to the list inside of ports Zephyr CP tools build CircuitPython. The build is failing. This error. I'm guessing that I have done something subtly wrong. I don't know exactly what it is. Looks like it's not pulling in the animated GIF library include correctly. Tried adding it to library source. Build. Okay. My complete build. Yeah, H versus C problem. Okay. Yeah. Yeah, that's a good tip. Other port makefiles. Let's take a look at that just to wrap my head around it a little better. Exist. Nice. Literally does not appear in the project. Really? You point me to a specific file that has this? Declaration? I have to find one. I am guessing the answer here is right, but this part feels a little hallucinated so far. Yeah, misremembered. Fascinating. That misremembering is the way that we phrase that. It's in defines make, and it doesn't use that name, gifio sources, so that's why my grep failed, and already in your flags. Check whether gifc needs dcircuitpy. I don't know what that means. I mean, you can read the code, my friend. What are... Check whether gifc needs dcircuitpy. I'm not sure how to check whether it needs dcircuitpy. I don't really know what dcircuitpy does. Interesting. So then presumably this is still going to fail if we just do this. I think is worth trying. And then if we need this, we're gonna have to add this loop. For source in library sources, top source, build file, .o, object file, objects append, tg, compile. Flags, port flags. Pass circuit Python flags. Okay. This actually did build. I think it's worth a try. Reallocation failed. $23. Oh, my guess is this is probably too big, honestly. It's 13K. Let's see if we can find a smaller one. Video. This one is way bigger. RAM do we have? Okay. Oh, sample room. But that's also huge. That's still bigger. The first one is by far the smallest. See if we can find anything smaller in the Learn Guide repo. I don't just have one for testing. I guess we could search online probably for a test GIF. Like memes. That's not really what I want. None of this is gonna work. I want like the big buck bunny of GIFs or something. I want like a test pattern type thing. That one's only 7K. We could try that. It doesn't look like it animates. So we're not really testing the full thing. That's true. Little memory allocation. This is 87K. It's also just rebooting constantly. Oh, it finally stopped. Okay. Hmm. Okay. I don't know a good way to find a small GIF without, like, I don't really, I'd just be searching the internet exactly. $2K. That's not the right, that's not gonna work. I don't know how to search for file names. Find? I don't think find works. I don't think it recurses really though. Next, find recursive. Dot dash name. What? Can I I don't know if this is gonna work. Oh my goodness, that actually did not work at all, actually. Okay. Also did not work. I feel like there should be a pipe or something. Yeah, that's basically more or less what I think I was after. So find, do the find, and then it is a pipe, and then it's xargs. Xargs. If first, and then pipe, and then xargs. So we were close. I was very close. Okay, smallest ones are here. Kinetic POV. Why is there a readme.gif? That's interesting. All right, let's look there and then also here. Circuit Python gifio. That's actually the guide that we were just in. I wonder if that's supposed to be MD. Yeah, that's got plain text in it. So 24K, 15K, that's 9cat, that's the smallest one there. Kinetic POV, I don't know about these. Are these going to be actual GIFs? Invert. Fruit. Red flag. This reminds me of Factorio. What you call it? Conveyor belt. Okay. Decoding and showing works fine. We're not testing multiple frames here because this is not an animated GIF. Could make it bigger. And we could try to find an animated one, although I suspect based on the size of these that none of them are going to be. This is backwards? It's like military arm patch. All flags. So none of these seem to be animated. I need like a small animated GIF. A thing that I can find easily. Maybe let's take one more peek through this. So those were the smallest ones. Is there anything smaller than 15K? No. Not at all. Not at all. This one, which didn't work, but also was not animated. All GIF? All animated GIF? That's gonna be too big. Most certainly. Maybe these will work. I think, thanks for the link, by the way. I think that these are one of the ones I pulled. Let's download this. Let's see how big it is. Oops. Oh, there's actually a zip here. Okay, let's check these. Oh, 160 by 128 sounds promising. Those are pretty small. Yeah, thanks for the link, by the way. No, I appreciate it. Oop. 162K. No, those are still fairly big. Let's see if we get anything in this one. $76.45. Suspect these will still be too big. Is this the smallest one? It's a tiny bit smaller. Can you edit GIFs in GIMP? Could I cut most of it out? Most likely that is because I'm guessing that this operation that was writing this in the OS was not actually done. And now the IDE is a little upset with me. And running. I don't know. I think it's messed up somehow. It's now empty. I think we probably killed this by saving when it wasn't really ready. One of the really nice things about PyCharm is PyCharm keeps this whole local history of all these files separate from files themselves, so I can actually just bounce it back very easily like that, which is super handy. Reallocation failed, yeah, 153. I downloaded this. I am almost certainly sure that it's too big. $181K. I need like the smallest thing I can find. Animated? Yeah, I don't know if we're gonna find anything small enough. What's up, Relic? I see. Hey Tim, sorry I'm late to the party. Hey, yeah, no worries. Eevee is at 64 by 55. I enabled gifio in Zephyr port, and we got a successful test with a non-animated GIF. So I assume that the animated ones are probably going to work okay as well. But the problem I'm running into is all the animated GIFs I can find so far are too big, basically. I need like the tiniest animated GIF that has ever existed. Or the other thing that we could try is this. I don't know if we'll succeed. You just combine a couple of random 64 by 64 and export. I don't know how to do that. I don't know how to do that. I mean, I feel like this is the smallest one we've found so far, and it was 13K. What if I try this? Can I just drop? I don't know which one of these I want. GIF maker? I don't really want GIF maker though, because I already have a GIF. Right now, this is 320 by 240. It's 13K. We tried something that was around 7K that also didn't work. So I would need to go to at least less than around half, I think. So what if we tried a quarter? Here's a 16. Nice. Thank you again, Noah. Let me download this. Might have messed up the chat on the stream there for a second. I'm not sure. 2.8K. Yeah, that sounds good. Let's do that. It's here. Let's call it heart. I'll try to let it finish copying here so we don't randomly wipe this file again with the IDE freaking out. Theoretically, it should go pretty fast though. So this. Nice. All right. Very good. Thank you so much for that. No, I really appreciate it. And we are good to go there. I have scale 3 on, so it's big enough that we can actually see it still, which is sweet. And it is totally pulsating in and out like a, I don't know, it's like a Zelda. Wasn't there like when you get hit or when you're sick or something in Zelda? I haven't played Zelda in a very long time. Okay, cool. So this is working. The test for it, the native sim test for it would be fairly straightforward. I think we would probably not, or EasyGIF. Yeah, EasyGIF I was headed to, but I wasn't sure the right things to cut, basically, but we did make it in the end. I do love that site, EasyGIF, though. It's a good shout. I think it was Anne who turned me on to that for Learn Guide stuff. I do use it quite a bit for Learn Guides whenever I need a GIF. Although I've also gotten better at just using FFmpeg these days. Tried for the last year or so to really hunker down and use FFmpeg anytime that I need to mess with a thing, and now I have a file with a bunch of commands saved in it. In any case, we're good to go there. That works. The test on the hardware is good. The native sim, I could think of 2 ways to test it, actually. So for a static GIF, we could basically do the same thing that the JPEG IO test does, which is just render it on the screen and make sure the screen matches a reference bitmap. Like it takes a screenshot of it, and then it matches the screenshot, essentially. That would work totally the exact same way with a static GIF. With an animated one, it, I think, could actually still effectively do the same thing because the code is calling next frame here, which means the code is in control of when this happens. So what we could do is load the GIF, compare the current screenshot of the first frame, call next frame, and then compare that screenshot of the next frame, call next frame, and keep... And basically, we have one reference screenshot for each frame, and each one can compare against that. So we can kind of test the animation as well inside there, which will be cool. All right. That will do it, though. We made it to an hour. I do, again, thank you so much to Noah for saving me there with a GIF. Super stoked to get this tested. I will add the native sim tests for it and storage I might talk to Scott a little bit about storage after. I'll give it a try and see if it just completely freaks out on me or not. If it doesn't, then I'll try adding the storage one. But if the native sim goes crazy on me, then I'll talk to Scott about it. All right, yeah, thanks everyone for watching. I will leave a little pulsating heart for us at the end here. As far as I know, Scott's planning to deep dive on Friday. I do think he had a potentially sick child he mentioned during the meeting yesterday, I believe, CircuitPython Weekly meeting. So that could be a question mark. But as far as I know, I believe he's planning to do Friday. So then I'll be back on Saturday over on my own channel. And then, of course, I will be here next week on Tuesday on the Adafruit channel. And I will leave you with a reminder to check out JP's product pick of the week later today, 4 p.m. Eastern, 1 p.m. Pacific. You can get a discount on a specific product if you would like to get yourself something on the cheap. That is it for now. So long. Thanks for watching. I will see you next time.